Finally, the simulation is completed and I'm getting this message that is called calculation complete. If we can just move up in the console, you can see that we are getting a message of convergence, that is solution is converged. Now the reflection of this message doesn't always mean that your solution is converged. You have to look up at some monitors. As we have monitored the velocity at the outlet, you can see that the velocity at outlet is constant with respect to the number of iterations. So this adds up as a good reason for concluding the simulation based on the convergence, right? So you can see the residuals or the equations which have fallen almost closer to 7 or 8, 10 power minus 8 or 10 power minus 7, right? That indicates this is a very good convergence, and although this case is very simple, it has to converged. Now as a sanity check, we can just check up the report of the fluxes, and for that I need to go to the fluxes in the reports and double click over there. What I will be checking in the fluxes, or what we can check in the fluxes, is the mass flow rate. Now mass flow rate at the inlet and outlet will be computed using this feature available over here, and you can see the amount of mass entering into the domain is 2.3 kgs per second, and the amount of mass which is leaving the domain is negative of 2.3 kgs per second. So the amount of mass entering is equal to the amount of mass leaving the domain, and this is what the continuity states us, the continuity equation. So this again indicates that the solution has converged appropriately, right? And these are the methods with which we can perform the simulation, and we can change the fluid flow material by going to materials and adding up the desired material over here. Now in order to visualize the flow field, we have two options. Either we can just work on the Fluent setup module itself, we can create the graphics of contour, or else we can move to the results, that is the CFD post, and we can create the contours or graphs or any other thing, right? So we will be just going to the CFD results. I will just close this one, and remember, we have solved the fluid flow, and that fluid is water over here, it is not air. Clear? And after closing the Fluent module, we can just go to the workbench schematic over here, and in the workbench schematic we can open the result section. So I'll just double click over here and wait for the CFD post to open, and you can see that the CFD post is opened over here. And now we basically can create any form of visualization. Now what I will be doing is, I will be turning on the inlet surface, so you can see the inlet over here as well as the outlet, and if you want you can just turn on the wall as well. But the wall is a complete closed section, we cannot see internally. So what we can do is, we can go to the wall. In the rendering options, we can increase its transparency to 0.75 or something. Now you can probably, after clicking apply, you can see the internal region of it. Clear? First and foremost task is, I can just create a plane, that is plane 1, and on the XY plane click apply. So you'll be having a plane in the internal region. If you want, you can just turn off the wall as well. Now we can create a contour, and the contour location will be on the plane. I'll increase the contour lines to 100, and I will be creating a velocity flow field over here, and the velocity is over here, and click apply. Now a simple contour will be depicted over here, and you can see the flow field, how the water is moving from left to the right. Clear? And as it is moving along the length, I believe its velocity is increasing. We can just probe the values. Click on this option of probing, and you'll be having this ribbon over here in the bottom, and you can just select the field variable what you want to evaluate, and click on the desired position. You can see it is 0.35. So there is a slight increment in the water as it is progressing along the length, and there are no major things that we can analyze in this simple case over here. as the main objective was to understand the different materials that can be added up over here. So now this is just a foundation. We will be learning different things again in future, so you can just understand what is happening over here. And if you want, you can just create a straight line as well over here and try to plot the variation of velocity along the length. So by default you can just click apply and see what is the line you're getting. The first point is at 0 and 0 0 0, that is the origin, and second point it has x, second point that is point 2 is at 1 0 0, that is this distance is x, that is 1, and y and z are 0 0, but the total length of the domain is 1.5. so I'll just change it as 1.5 and click apply. Now that I have this line over here, I'll just go to charts over here, click on apply, and in the data series I will be selecting the line 1 what we have created. In the x we will be selecting the geometric x, so this will be the x-axis of the length of the model, and in the y-axis we will be representing the velocity flow field. I'll click apply, and here you will be having the velocity flow field, velocity variation. So at the inlet it is 0.3. if you remember, we have entered the velocity in the boundary conditions of inlet as 0.3, and along the length it is increasing in this fashion. This is all about the basic differences. And what else you can do is you can try to create streamlines as well if you desire. Click on streamline. The location will be starting from the inlet. By default you can click OK, and you can see straight lines being created over here, right? So this is all about the simulation of water in a pipe, and we will be moving to the next case wherein you'll be understanding the different important aspects in CFD simulations. So with this knowledge, I'll just conclude the video over here, and let us just catch up in the next video.